Oh, hello everyone. Welcome back to my channel. I am OBINexus Nnamdi. We can call me Nnamdi. Uh, so now I want to show you how to use a Node.0 package to authenticate and authorize yourself. We're gonna pretend we have two parties, Alice and Bob, and I'm gonna show you how to use Alice and Bob to analogy to talk on a communication without any proof, any setup system. Okay, now I'm going to remove examples slash Alice. I'm going to remove slash star uh, example slash Bob. And this is just removing every file in examples directory. Okay, okay, I think it's doing one by one. So that's working now. So I'm now removing examples. So if you look here, this, go to these files here. These files are the files in Node.0 package. The first file, what you need to do is to build a system. So you go to npm install. I go to npm run build. So install it and you build the package. So it's now building. A lot of errors, which is just roll up errors only. Now I get to now I get the files. Now I get to something called the command line interface bin 0. Now, if to use this, I go to npm 0 dash help. Not to use it, I go npm 0 dash. So I get help. So we're gonna go to examples directory. I'm gonna actually get in here. So I'm in examples directory, and I'm gonna do ls recurse. So now I get so this the command line interface. You just have an npx0 to use it. Now I'm going to see the examples. I'm going to see the Alice. So Alice has created an identity file first. So the first thing Alice has to do is create something called an identity.json. Do identity.json. So we're gonna call it Alice Smith. And she's gonna just be Alice Smith on that's identity. Alice Smith. It's just information to identify her on the network. But she was then she's gonna add an age as a 25. I'm gonna add an age as 25. So Alice Smith is not 25. Look at Alice. Look at the. Oh, did I not save it? That's. So I'm gonna move this identity adjacent to Alice identity JSON, and then we're gonna cut Alice identity JSON. And this is the point of it. Its match is correct. Now I'm gonna go to CD Bob because Bob has to create an ID file too because it's a Bob Alice communication. I'm gonna do Bob identity. So this is Bob. No. So Bob's gonna create his own ID file, and this is to identify Bob. So it's any identifying file. The Bob is name Bob Smith, age 21, age 30, age 15, age 28. So this is not Bob's ID and Alice ID. If you go through Alice, if you go ls dot request, you get the two files, Alice and Bob, and it's all JSON file. So anything to identify it, it's an identifier file, but you can use cryptography too. So what if I want to talk to Bob? It's then simple. You go to cd Bob Alice, and you go npx 0 create. So first command you need to use is create. But you can do create slash help. So just to create an identifier file. So the input data you want to send is npx. So this is an input data you want to send. You want to protect. So it's just data you want to send. It's an identifier, but it's really just to make it easy. So you can put a message in that file. So you go npx 0 creates dash import alice identity dash output alice ID, the ZID. And this will create an identity file. Now you create it. Now you go to Bob. Bob has to create the same thing. Create from his let's import Bob ID. Bob ID. That's your ID. Okay. So now they have ID files. Now you can talk. Now you can try to. Now you have to establish a accommodation with that file. So what they have is Alice ID key file and Bob. So what you do now is so now you go to see the Alice. So now Alice has a key file and a ID file and a. So this key ID is ZID is the file you use for Alice to public key, and this is a key file. Always keep your identity, your data, what to send, and your key file. As private. You don't never send this over the network. You never try to send that, or your data will be really revealed. You can only send your public key. So what Alice has to do is now derive a key. You can derive an input file from Bob, because Bob has Bob. So you look at the npx 0 derive command. So this is the input ID file. Derive command for. Input ID. So uh, so she can use so this is a key file for herself on the network. But she if wants to if you want to be verified, she wants to be verified. She can do the npx uh, uh so first of all you go to npx 0 verify, and the verify is just verify the data. So it works. So you do like this. You can npx 0 verify and npx 0 verify. You have writing the right data. That's key file. Uh, 0 ID. This is a key file. So you can use the key file. Okay, and that's input. That you need to input data to verify that is for that. You got the input data. And the input data was sent in for that file is Alice identity. Alice identity. So this means that the ID is valid. So this also means that this ID file and this key file are associated with a public key. That's a key file. So you can do that again. So now I'll show you the npx 0 command. Derive. This the derive command is for deriving people to adding people to the network. So you got the authentication verification. Now you got you have to have a derive command. Derive command adds people to the network, but you don't. It's a ZKP commutation, so you have to derive a command. Derive a purpose. Auth auth. Authentication is just a proof, like a proof who we are, and the input file. So it's a public key. It's trying to derive from a private key. It's what key if you have a so if you do the input file. So now it should now Alice for Alice to derive this key. The input file is provided. And this she can use Alice ID the GID file, which is the input ID file, and the algorithm you have to provide because all default options, and the with key option is you can use the with key option. With key or just key to the to to derive a private key with that can be verified too. So you're going to derive a key both from an ID file for talking to Bob, because you got a public and private key. You can derive. She, okay, she now okay now okay, sorry about that. The output file. You can provide the output file on Alice Bob Handshake. .zid. So what you're deriving is the ZID file. He's trying to talk to Bob. So now you got an Alice Bob handshake. And this file is here with a key file too. The key option with key option is there. Now you can send this to Bob over only the public key, never the private .key files over to Bob. So what you're gonna do is now send this to Bob. So see, Bob is not gonna receive this key, and then he's gonna try to verify. Uh, uh, um, uh, so okay, so she's gonna verify. So you're gonna give verify command. Uh, uh, no, the Bob doesn't have the input data or this, but she's just gonna put a challenge. Uh, 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 let me think. I think I remember how to do it. So I'm going to put Alice. So I'm not Alice. So Alice has not sent this public key handshake. So when she creates this handshake to talk to Bob, someone created. So Alice has to send something called a challenge. So what she has to do is create a challenge. So this is challenge command. Yes, just remember how I did it. But the challenge is important. The challenge was sent. We verified it. So challenger. So this challenge command is just generates a challenge, so Bob can be authenticate the system. Uh, uh, so I don't know. So yes, we have to go to Bob to do it. Because Bob has to send a challenge. Because Alice sends a public key. Bob then Derive says create a challenge for Alice. Uh, challenge. So challenge. Is it a file? Uh, so Bob going to create a challenge. So challenge file. So you're gonna output a challenge. Uh, output a challenge. Gonna put output a challenge. Uh, Challenge to prove it's Bob. Challenge for Alice to do. Challenge the bin and ch- challenge for Bob for Alice. Because Alice now send a public key file and then this is a S64 bytes of randomness that shows it into the so it can challenge for Alice. And she's gonna derive. Yes, so, so this challenge is not sent to gonna be sent to Alice. So when Alice does this challenge, so Alice is gonna send a challenge to Bob, uh, and he's gonna prove it's him with that key file. So this Bob Bob's creates this challenge, so and then CD Alice and Alice gonna try to prove it's her because Bob already has a CID key, a public key to Bob. With Bob public key. So that's what we're gonna do. Which is root public key as well. So NP gets zero to challenger. So you're gonna try to prove it to her. You're gonna prove so you're gonna receive the challenge. Uh, she's gonna try to prove it to her. She's gonna try to zero proof inputs challenge. So this is the input file. Um, so yes, so this proof gonna be for the challenge. So it's gonna proof to prove gonna get challenge, and the challenge gonna be dot slash bob slash bob challenge challenge for bob and the bin, and the format is gonna be binary. So the default format is binary already, and the input file is the ID file. It's gonna be receive a wait. Oh, so again. So if zero ID file to prove to create proof. So the ID file is here. There's Bob. So if Alice is the one creating the ID file, then Bob has to be the one to create a challenge. Then Alice has to be able to create a challenge. Uh, because this is the challenge for Bob. And oh wait. The thing is that if Alice now sends Bob the challenge, and then Alice, if Alice now sends Bob a challenge, challenge file is for Bob, and now Bob has to prove to Alice. So this is now challenge for Alice in Bob, and the ID file to is sent is oh the, okay, yes, so Bob has want to derive the ID file. So we're gonna use that to Bob. So Bob has an identifier file. So Bob, so npm 0 challenge derive. So there's public purpose authentication dash purpose author ID dash key file. Oh wait, so what? Oh, shit. Sorry about this. So again. So Alice sends the Bob. Okay, so Alice sends Bob the. Okay, I'm sorry, everyone. I just got locked in my track. I got train of thought. So my train of thoughts. So this is what it is. So if I remove the handshake here, this is just derived of sim derived. So we need to remove the handshake because this is for because we need to practice derive a new key for every communication, so you don't have a monolithic system. So this is Alice handshake file. So it's gonna go to Bob now, and Bob has to now derive a new key to speak with Alice. So I'm gonna call this one the Bob Alice handshake because they agree. Input file. The input file is the ZID file dot slash Bob dot ZID, and the format. The format does not matter. The purpose is of what can be just a string, and with key, because with key, and it's output Bob as handshake. That's the idea. Now this so now we have, so now in this two directions we now have a Alice Bob handshake and which is not so it doesn't affect the root key. So now Alice wants to send to Bob, so Bob has to challenge Alice has to wait Bob Alice sends the public key to Bob. Now Bob has to use this one, the Bob Alice handshake key, to establish communication. So Alice have to reply with a Bob Alice. You can go down like this, but it's for different purposes from this root key. These two keys are only for Alice, but you can use that for a public key. She also send a public key as well. There's no option to lock it down, yes, but you use it like that too. So npx now. So now you got npx 0 derive. So you go to the derive command. So now you want to do now I just want to create a challenge. So uh, um you can verify. I already verified before. So now we can create a challenge. So now so npx 0 challenge challenge. Am I doing this right? Okay, I'm gonna remove challenge for Alice for now. I'm gonna do that again. I'm going to do npx 0 challenge, challenge for Alice, and that is challenge Alice. So we're going to use the root files, and this challenge is not sent over the network. So we're gonna yes. So this challenge now. So this, if you now go to the Alice. Now Alice has to now send a challenge to Bob. So Alice has to now accept the challenge from Bob. So no proof identity. So she's gonna consider proof help. I'm gonna look for the help proof, and then she's gonna try to npx. Is that a binary format? Yep, it's binary. So it's gonna judge a proof with input file, zero ID file that Alice gave her. So you're gonna send this zero ID file for the handshake to accept handshakes, and that's in Bob Alice handshake, and that's gonna give her, that's the input file you're gonna use, and she's gonna compile is the challenge that Bob sent her, which is the Bob Alice challenge challenge file challenge challenge file challenge for Alice, and the format is gonna be binary, and that is and the output file is gonna be proof. Proof for Bob. Proof for Bob. Proof for Bob. That's proof for Bob that proof the Bob bin. Always add the bin file because now this proof is now successfully generated. So remember, you derive a coding, you derive who you want to you then create a handshake files, and then that handshake established, and then you go ls, and you can see I got a proof here. Now this proof then is then set to Bob to verify its knowledge. So now you're going to do Bob. And now I'm going to use that proof file to verify that proof. So you see this proof file is now created. So now I'm going to do npx 0 verify proof. Okay, help. So I want to get help. So so Bob has to understand the challenge first, the proof. So to verify the proof, Bob has now take a input file. The input file the input part is the proof file, the proof that was created as // Alice proof for Bob. And now they're not trying to establish secure communication. And the ID file for verification, ID file, the ID file for verification was sent to Bob, and Bob remembers that, stores the memory, and that's a handshake file because they did a handshake, and the help, and that is fine, it should work. Sorry, verify notes. Or input proof for bin. Oh, that's just I. This is just I. Sorry, guys. And the challenge, yeah, the challenge was very important. The challenge is what they needed. So who created the challenge? It was Alice. It was Bob. It was Bob that created the challenge for Alice. So it's just a challenge for Alice and the bin, and it should work. Oh, if the proof fails, then yes. Sorry. This is Alice. This is Alice. Because it's Alice handshake, you can't verify it because Bob has to use tries to use his own handshake, and that's the Bob Alice handshake. It succeeded. So because so there's a proof now. So now Bob now can decipher the message because the proof's not successful, and now we can finally send the proof. So the proof we send the proof. Now we send the proof. We can now have a proof. So this is the file for Alice. So ls because and this is the proof. You got Alice, Bob. You see a settlement, and then change for Alice, and then now prove that it came from proving that Alice, Bob has not proven himself using Alice, using the proof and his handshake that he made with Bob, and now they can communicate together and send messages. Now you can always derive and remove a file people from the network too. And that's the npx 0 client help. So that is the npx 0 client, and that's how it works. But the package it's a package, yes. 1 second. Yes, and that's how it works. The package works, and so Alice and Bob have not proven themselves. Now I can start establish secure communication and start sending keep sending message. So that message can be just sent from that input file can now be sent to Bob, and they can start having conversations. Because the data is now safe and secure. It doesn't matter what file it is, you can send. I have a file system too. This is a big major because because some governments are trying to decipher people information. No zero. It has quantum. So one application in blockchain. So the first application in blockchain where you have ZKP proof systems. That are this one offers no setup. That's no zero. And if you get the business one, you get formal proof. Also, if you have a file system, online file system, and you want to transfer your files, you want to intercept with the backdoor on the network. You need and you have a ZK system. You have trust in the system, so the user can also get to the files or the folders on the service. Maybe a Google service or Google Drive service. I don't know what service you use. Can you implement a full KC encrypted setup system with the ZK proof, the business proof plan, the business proof provided in the document. And finally, you can do like you can encrypt data, any data on a system, and only the end user will be able to get it on the file system, on the file server. And the final one is it's a secure custodial system. So you can secure like a file folder, encrypted data with the system, and you can only know information on the system. And then the last one is yes, it's quantum resilience. Can use some primitive cryptography like SHA-3 algorithm for the replication and the occasion, which is has quantum security properties. Or you can use SHA-256 if you're on a blockchain, you can use quantum security, you can use the SHA-2 primitive, and you can you get set up on a quantum system with the zero knowledge proof for security purposes. So you can do a lot of this with the proof documents, but you can use this into a package too. So you can import the node zero into your own source code and consume it for your own maybe Express app or any application you need, Axios, a server. I don't know what you want to use it for. Use it for a lot of things to secure yourself and your people, on your clients, on your data. It has a lot of applications too on a real network. It's production ready. You can use it now and use it to secure yourself on a network. And that is that is Node Zero in a nutshell. In a video, that's using a client to you can use the API from in the library to consume it at OBINexus Node Zero. You import it into your own packet and just consume an API and make your own applications too. That's the end goal of everything. So it's not really it solves a lot of problems and you get trust in that system. So thank you for watching. Help me like my videos, subscribe and share. And all the best. Goodbye. Thank you very much. And thank you for watching this video. If you like the content, you learn something new, subscribe, share, and so others can understand and share my videos so others can understand a bit better about what I'm trying to do and grow my channel. Thank you very much. And take care. Until next time. Uh, until next time. Goodbye for now.